So if you're running any serious AI workloads in the cloud right now, GPUs are, well, they're your most precious and most expensive resource.
Absolutely. But there's this massive kind of hidden cost that comes with them.
Right. The traditional way we allocate them is completely all or nothing. You give an entire GPU to just one container.
And the data shows something like 60 to 80% of its power just ends up sitting idle.
It's an astronomical amount of waste.
It is. And that's the central problem of multi-tenancy,
Yeah.
How do you let lots of different users share that very expensive hardware safely?
Okay, so we have a few ways to tackle this. The first is hardware partitioning, right?
Like NVIDIA's MIG, it's really the gold standard for isolation, but the catch is it's limited to their most expensive chips.
A100s and the H100s.
Exactly. Then you have your second route.
Which is just time slicing. That gives you tons of flexibility, but you get absolutely zero guaranteed isolation.
None. And that brings us to the third route, which is where all the focus is right now, software virtualization.
Systems like HAMi-core and the newer one, the FCSP.
Right. And our mission today is to dive into this framework called GPU-Virt-Bench, which is designed to measure how well these software solutions stack up against a theoretical ideal.
The MIG ideal. So that's like a perfect, frictionless, 100% efficient hardware baseline.
That's the one. And the benchmark scoring tells you what really matters for production LLMs. It heavily weights three things.
Isolation, LLM performance, and overhead. Those three are getting scores of 20%, 20%, and 15% respectively.
Yeah, if the software fails on those, the whole system basically fails.
So let's talk about that crucial overhead metric. The software layer works by intercepting every single command sent to the GPU.
It does. It uses these things called DIL-SIM hooks to check memory quotas and resource limits before any work can actually start.
So it's kind of like having a door warden check your ID every single time you enter a room. That has to add friction.
It does. Natively, launching a task kernel takes about 4.2 microseconds.
Okay.
The first-gen software, HAMi-core, it pushed that all the way up to 15.3 microseconds.
Wow, that's a 3.6x overhead just to check permissions.
It's a huge hit. But what's really fascinating is how fast the optimization is happening. The newer solution, FCSP, cut that latency almost in half, down to 8.7 microseconds.
So they're getting much faster at checking the ID at the door.
Much faster.
Speaking of checks, how good is the isolation really when you're just relying on software? Hardware MIG gives you perfect, guaranteed boundaries.
Right. The benchmark describes software isolation as approximate.
Approximate. Wait, so 85 to 92% accuracy in controlling compute usage? I mean, doesn't that sound like a major vulnerability for mission-critical jobs? Is approximate really good enough?
Well, it really depends on the workload. And for LLMs, the sensitivity is just immense.
Right, because they're constantly growing their key value caches to remember context.
Exactly. So if there's even a tiny memory bottleneck or a latency spike, the LLM feels it immediately. The whole generation process stutters.
And I'm guessing that sensitivity is where the improved overhead really starts to pay off.
It's huge. The true measure of user experience here is time to first token, or TTFT.
How quickly you see that first word appear.
And that's where FCSP really shines. Its better memory handling and lower latency hooks led to 35% better token generation latency. We're talking 28.7 milliseconds TTFT.
Compared to what for the older one?
Compared to 45.2 milliseconds for HAMi-core, it's a very noticeable improvement.
So if MIG ideal is that perfect 100% score, what's the final report card look like?
Okay, so using that weighted score focused on production, FCSP gets an overall score of 85.0%.
A solid B plus the 1. That's actually huge.
It is. HE-core, by comparison, scored a 72.0%.
So the big takeaway for you, as someone actually deploying this stuff, is that software virtualization can get you 85% of ideal hardware performance. And it lets you do that on cheaper, more widely available GPUs.
It's a fantastic trade-off for cost and flexibility. The data is pretty clear. For any multi-tenant LLM inference, you should be preferring FCSP.
Which leaves us with a really provocative thought for you to chew on.
If hardware MIG offers that superior isolation and that perfect 100% throughput, at what point does the higher cost of those dedicated high-end GPUs outweigh that remaining 15% performance gap you see with the best software?
Right. When is an 85% solution truly good enough to replace dedicated hardware for your most critical LLM deployments?